Welcome to Physics in the Park!
Adult supervision is recommended for children from 5 to 12 years old.
Newton's first law states that an object at rest will stay at rest unless acted upon by a force.
Similarly, an object already in motion will remain at a constant speed unless acted upon by some force. The question of the day is, what does it take to run up a slide? First, you need a head start. When you're standing in place on a horizontal surface, you already have a normal force equal to the force of gravity pulling you down. Having a head start gives you more time to accelerate. And because force equals mass times acceleration, and your acceleration is greater with a head start, your force going up the slide is larger than the force of gravity pulling you down, allowing you to reach the top.
An alternative way of explaining why you should have a head start has to do with the law of conservation of energy. For a particle at the top of the slide, PE potential energy is set as mgh. Now, if we look at the equation associated with conservation of energy, KE initial plus PE initial equals KE final plus PE final, for this case, PE initial equals 0 because your initial height is 0, and KE final equals 0 because your final velocity is 0. The equation is reduced to KE initial equals PE final. Because PE final is set, KE requires a minimum initial velocity at the bottom of this slide for this equation to be true. Having a head start likely increases your chance of reaching the initial velocity to succeed at running up the slide.
Step 2. Get a grip with the right shoes. The force of friction pointing in the direction you're going prevents you from slipping down the slide. When you press down onto the slide with the ball of your foot, the friction acts the other way, setting a grip for you to lean on. On a molecular level, the molecules on the bottom of your shoe interact and bond with the slide. Without this force of friction, you would slip down the slide because your foot wouldn't be able to stick to the slide, enough for you to take more than one step.
Thanks for watching Physics in the Park!